Hey, it's Mr. Shrum, and welcome back to the Introduction to Biochemistry tutorial in biology. Right now, we're going to look through the lesson activity together, and it is all about chemical reactions and balancing these chemical equations. So if we click on the simulation, it'll pop up with a PhET simulation, and in it, we are shown three separate processes: making ammonia from nitrogen and hydrogen to give us NH3 ammonia, separating water from H2O into hydrogen and oxygen, and then the combustion of methane. Methane is CH4. You add a little bit of oxygen, and you get these products, CO2 and H2O. That will be the result of all combustion reactions, so CO2 and H2O. And within the simulation, we are given a few tools. And my favorite tool is this balance, the weight balance scale. And this reinforces the idea of balancing. You need the same amount on this side of the equation as you do on the other. So if we add nitrogen and we add hydrogen, we have two nitrogen molecules and two hydrogen on the left side of the equation. If we add ammonia on the right-hand side, you see that is not quite balanced. So we have two nitrogen over here, one nitrogen over here, two hydrogen over here, and three hydrogen over here. So we'll have to add another ammonia to the right-hand side of the equation that has balanced our nitrogen, but our hydrogen needs to be balanced on the left-hand side. We only have 2 on the left and 6 on the right. Good thing we can just add 4 more hydrogen. And here we go. So we get a little smiley face telling us that we are good to go. And the next process is separating water. So if we add an H2O molecule here, hydrogen, oxygen over here, we see that hydrogen is balanced, but not oxygen. We have 1 oxygen on the left, 2 oxygen on the right. How do we solve that? Well, we're going to add another oxygen to the left-hand side. Now our hydrogen is not balanced, but thankfully hydrogen is on its own on the right, and we can just add 2 more hydrogen to the right-hand side to give us the balanced equation. Okay? And our last process here before we move on to the game, we have methane, oxygen, CO2, and H2O. Okay, so we are balanced here, carbon, but not balanced for hydrogen or oxygen. And what we need to do is add an oxygen over here, and there you go, or H2O over here. And now we have balanced carbon, hydrogen, and oxygen. So we have 1 methane molecule, 2 of oxygen, 1 CO2, and 2 H2O molecules. All right. So on part A, based on your experience in the simulation, what do the numbers 3 and 4 refer to in 3 NH4? Well, the 3 gives us the number of ammonia molecules, right? There are 3 ammonia molecules, and each molecule has 4 hydrogen. So 3 tells us how many ammonia molecules there are, and each molecule has 4 hydrogen atoms. Part B, the scale shown in the introduction measure mass or the amount of matter in a particular object. The scientific law of conservation of mass states that matter cannot be created or destroyed during a chemical reaction, but it can change from one form to another. Did the simulation support this scientific law? Why or why not? Well, yes, it did. Both the scales and the graph in the introduction showed that the mass of the products and the reactants were equal, even though the forms of the molecules changed. In the simulation, atoms and molecules formed new molecules during the chemical reactions, but the number of each type of atom stayed the same on the left-hand side and the right-hand side. Precise measurements are important for scientific accuracy. Use the game to explain why precise measurement of reactants is important to form the desired products in a chemical reaction. So we didn't go through the game, but the game showed that the desired products cannot form if we do not begin with the correct number of atoms in the reactants. This means that scientists need to precisely measure the reactants before the reaction starts so that it yields the desired products. You need enough starting material to produce what you want to produce. Based on the simulation, write a definition for the term balanced chemical equation. A balanced chemical equation is a way to show how the number of each type of atom is identical in both the reactants and the products of a chemical equation. Part E, we have a combustion equation. Methane plus oxygen equals H2O and CO2. How would you correct the products? So, looking at this, is everything balanced? No. So, carbon's balanced, but oxygen is not, and neither is hydrogen. So to balance this equation, there should be 2 more hydrogen atoms and 1 more oxygen atom. This imbalance can be corrected by placing the number 2 in front of H2O on the reactants side. And that's it for that lesson activity. If we go to the next lesson activity, it's titled An Unusual Diet. And in this activity, we have a video, energy, and the unusual diet. And then there are some following questions. So we'll look at that right now. Let me share the screen sound. And we should be good to go. Okay, so yeah, pretty interesting. I mean, I like potato chips, but I don't know about surviving on them alone. Part A, assume Deb eats 3 150-gram bags of potato chips each day. Use the USDA food database. If you click on that, USDA stands for the U.S. Department of Agriculture. They collect food data and things of that sort. So we'll use that for this lab to calculate Deb's calorie consumption and the number of grams of protein, carbs, and the total fat that she eats. You may use any brand of potato chips in the database, but state the brand in your answer. So let's check it out. we're just going to use this first one. Oh, okay. Sample food. Actually, I'm not going to open that. So for this one, another way to get around this is just to use your own sources. Potato chips, or crisps, as Deb said. Back calories. Okay. There are Okay, so depending on where you look, you might get different answers. So for this potato chip, it says one bag of 150 grams of potato chips is 820 calories. That's a little more than the example one we got. So we can look around for more. 150, so 800. So what I'm seeing, at least in the United States, about 800 calories for 150. Let's get back to the, okay. But if we just look at this example here, we'll assume this is correct for now. She will consume about 1,930 calories per day for a total of 32 grams of total fat, 32 grams of protein, and 353 grams of carbs. And protein, for each gram of protein, there is 4 calories. Same goes for carbs and or sugar. And then fat is the odd person out, the odd nutrient out with 9 calories per gram. So there's a lot of energy stored in fat, which can be good for certain occasions. And it's recommended for most adults that carbs make up roughly half, maybe a little more than half of their diet. Protein make up 10% to a third of their diet, and then fats make up about 20 to 30%. Does Deb's diet meet these recommendations? Support your statements. So if you break down the calories for each nutrient, if you multiply, so we have 1930 calories total. You have 32 grams of fat, and there are 9 calories for each gram. You're left with 289 calories of fat consumed. And if you have 30, I think it's 32 grams of protein times 4, oops, that will give you about 290 or 128 grams of protein or calories. Sorry, that's a lot of grams if that were the case. We have 289 calories of fat, 128 calories of protein, and we have 350 grams of carbs times 4 calories per gram equals 1413-ish. Okay. And then if you divide these numbers by the total, 1930, you get 6.6% of her diet coming from protein, 15% of her diet coming from fat, and 73% of her diet from carbs. So this is pretty low protein, pretty low fat, high carb. And I suppose this works for some people. But I see a lot of differentiation out there and different diet recommendations depending on what kind of health issues you're dealing with. And there are 2 health effects that Deb experienced, and she listed those in the video. Explain how nutritional deficiencies, when you don't eat enough of a certain vitamin or mineral, what can happen. Deb is fairly slender, as you saw in the video. Not exactly emaciated, I would say, but on the slimmer side. And I don't think she works out all that often, but she does have a physical job. So I would say she's on the slimmer, slender side, little fat, but also not a ton of muscle right there. So this may reflect a lack of sufficient protein in her diet. But I'm more worried about her nails not growing, her hair not being as lush and nice as it could be, and her gums are bleeding every time she brushes, or fairly often. So that's no good. You know, her weight and muscle mass, that's people come in different sizes, so you can't always rely on looking at someone's health. But these symptoms are way more troubling to me. What do you think is meant by the statement, the human digestive system is very efficient at squeezing everything it can out of any food? How do you think this relates to the way biomolecules are broken down and used by the body? The statement means that the digestive system can adapt to extreme diets in order to survive. So before we had an industrialized agriculture and industrialized farming practices, our diet was more inconsistent. And then over the course, we did develop subsistence farming and agriculture, where we were able to grow our own food and survive in different seasons and harvest crops to hold us over in times of need. For example, carbs can be broken down into sugar and used for energy. But when carbs are not available in the required amounts, it can also break down fats to provide the body with the required amount of energy. So the body does want to retain a certain level of fat to use for stored energy later if food is not provided. This explains why Deb has enough energy to keep going, even on her extremely limited diet. All right, so those were 2 lesson activities here. Pretty interesting stuff. I hope you enjoyed that. But if you have any more questions about this introduction to biochemistry tutorial, send me an email or a message in Canvas, and I will get back to you as soon as possible. But until then, have a good one, and I will see you all later. Bye-bye.